Hello, good evening, the viewers. My name is Bahitya Patrick. I'm presenting this video. It's a project that I and my colleague Solimo Rajab we are working on, and I hope the viewers will take it in and appreciate our energies, and where of course possible we are aware that it will be out there and be ready to be critiqued, but I would like to welcome anybody who is out there to this presentation. Once again, my name is Bahitya Patrick, and I'm presenting this with my colleague Solimo Rajab. First of all, this project is about early detection of disease. We are trying to look at a possibility where we can detect, first of all, predict and detect the disease. And we are trying to make it general. In general, the disease. We are not specific on whether it's cancer or diabetes or kidney failure and many other very, very, very dangerous diseases. So generally, we are trying to come up with this tool to be able to predict and detect the disease using machine learning technology. First and foremost, we shall feed the data, a large amount of data, into the system, to the tool, and we shall be able to detect the disease or predict the kind of disease given the characteristics. Of course, each disease has got the signs and symptoms. So we shall feed in large amounts of data and use machine learning algorithms to be able to detect, predict and detect the disease with the highest level of accuracy and precision, given the signs, the different signs and symptoms of the disease. First and foremost, the project will employ different data sets from the Kaggle machine learning database. So this is the implementation strategy, and the database is one of the most thoroughly investigated and primary data sets, and this is going to make it easy to perform conventional and sophisticated machine learning algorithms. That's the Kaggle machine learning database. And we hope and believe that given this kind method of implementation, we shall be able to receive, to identify, predict and detect, in other words, identify the disease with 100% accuracy, precision, and recall. Factors to consider before selecting the database, the data set. First of all is the quality of data. Of course, here we are talking about the measure of the condition of the data based on the factors such as accuracy, completeness of the data, consistency of the data, reliability, and whether it is up to date. These are the characteristics as far as the quality of data is concerned. Accuracy, here we are looking at how crucial the data quality characteristics, the quality of the data, the closeness of the data, how the closeness of the data to the expected result. Okay, if we get the output, how close is it? How close is it to the desired outcome? So that's the accuracy we are talking about. Then completeness, the comprehensiveness of the information. check whether all the data you need is available. And then the reliability, we are trying to check that the dataset information doesn't contradict another piece of information in a different source or system. Then another factor is the data distribution. We're trying to specify all the possible values for a variable and also quantifies the relative frequency. So the probability of how often they occur. We're talking about the disease in terms of the signs and symptoms. Now, features in the data set. Well, I have only about, I think, 10 minutes, so I'll make it quick for this presentation. The features in the data set. The data set is large for the project indeed, and it is freely available. It's freely available, comprising identified health-related data associated with over 40,000. It contains high temporal resolution data. This includes the lab results, electronic documentation, and besides the monitor trends and the web forms. These are some of the features. And then this subject about the Bayesian theorem and application to the project. Well, the Bayesian theory and probability are named after a British 18th century mathematician, Thomas Bayes. It describes the probability of an event based on prior knowledge of conditions that might be related to that event. So the Bayesian logic can show the result of a patient's test with a pretest probability to predict or determine the chance of finding a disease. Bayesian theory implies that Bayes' theory can be used as a rule for inferring or updating the amount of belief in the light of new information. How do we apply the Bayesian theorem? Bayes' theorem is a method to determine conditional probabilities. That is, the probability of one event occurring given that another event has already occurred. Because the conditional probability includes additional conditions, in other words, more data, it can contribute to more accurate results. Thus, conditional probabilities are a must in determining accurate predictions, probabilities in machine learning. This is the best method to relate the condition probability and marginal probability. Naive Bayes and application to the project. How are we going to deal with Naive Bayes, and then how is it going to be applied to the project? The Naive Bayes classifier is a Bayesian-based probabilistic classifier based on a given record or data point. It forecasts membership probability for each class. The most probable class is one having the greatest probability. Instead of predictions, the Naive Bayes classifier is used to project likelihood. Let me first switch off some notifications. Sorry for that noise. Now, how is the Naive Bayes going to be applied? First, it is simple, computational efficient, and requires relatively little data or training. I beg your pardon on that. Do not have a lot of parameters and is naturally robust to missing and noise data. So it helps to predict the patient's risk level for certain diseases through taking into account evidence of many attributes to make the final prediction, and provides transparent explanations of its decisions, and therefore it is considered as one of the most useful classifiers to support physicians' decisions. Well, a naive Bayesian network is a Bayesian network with a single root, the parent. All the other nodes are the children of the root, and there are no edges between the other nodes. So the edges in this network may or may not represent causal influence. And this network is used to model classification problems. And in such problems, the values of the root are possible classes to which an entity cloud belong, while the leaves are the futures or predictors of the classes. The difference between Bayesian theorem and the naive Bayes is such that Bayesian theorem describes the probability of an event based on prior knowledge of conditions that might be related to that event, whereas the naive Bayes is a classification algorithm for binary, in other words, two-class and multi-class classification problems. The naive Bayes is Bayesian-based probabilistic classifier based on a given record or data point. And it forecasts membership probability for each class, and the most probable class is one having the greatest probability. The references of this research, they are quite many, and they are quite many, but they are already captured in this presentation, and this marks the end of the presentation. I am going to share the slides to the platform that has been given, and therefore first, as I conclude, like I said before, that my colleague Solimo Rajab is together with me in this project, and we hope that we shall reach the implementation and conclude the project successfully. I beg to submit. Thank you very much.